I am Anil Kumar. Welcome to my series on logarithms. In this video, we'll discuss change of base formula. It is extremely important formula. In the first part, we'll derive the formula, figure out a special case, and then we'll have related questions. So once again, the questions which we are going to discuss are: first, to prove the change of base formula, which is basically log to the base a of x is log to the base b of x divided by log to the base b of a. By doing so, we have changed the base from a to b. Perfect. Then we'll have a special case where the formula can be rewritten as 1 over log to the base b of a. And with this formula, we have few related questions and we'll solve them one by one. You can always pause the video, copy the questions, solve them, and then look into my suggestions. So let's begin with the proof for the formula itself. Change of base formula is given as log to the base a of x is equal to the ratio of log to the base b of x divided by log to the base b of a. So we are given one log function which is log to the base a of x. We can say let it be equal to y. That really means that we could always write this as x is equal to a to the power of y, right? So this is the, as you know, exponential form. Now what we really need to know is how do we write log to the base b of x related to base a. So let us take up log to the base b of x now. Now we could always substitute the value of x, which is equal to a to the power of y, here. If we do this substitution, what do we get? Well, we get log to the base b of a to the power of y, right? Now, we can write using power rule log to the base b of x as equal to y times log to the base b of a. Perfect. But as you know, y is equal to log to the base a of x, right? So this is known to us. This is from where we started. So we'll substitute the value of y as log to the base a of x. Now what do we get? We get log to the base b of x equals to log to the base a of x times log to the base b of a, right? This is also a very interesting form where what we have done here is we have written log to the base b of x as product of log with the base a of x and with b of a. Do you see that kind of interesting pattern? But what we really need is the formula for change of base. We can isolate log to the base a of x and write the ratio with the base b. Perfect. That is what we are going to do now as our last step. So we can now write this as log to the base a of x is equal to log to the base b of x divided by log to the base b of a. And this is what we call as change of base formula. Perfect. Have a good look at it. Now in this page, we have few related formulas which are all very important. This is commonly used. Log to the base a of x. So we have changed the base. So at this stage, we have a base which is a, And here, what we have base as b. So you could change the base and get your result. Now, this is very important since on calculators, you have base 10 or what you have is ln, which is base e. So therefore, if I give you anything in some other base, even base 10 and base e on the calculator keys can be used to evaluate it. Perfect. So that is the whole idea. Now let's take up a very special case of this change of base formula. We need to show that log to the base a of b is 1 over log to the base b of a. This is what we need to show. So let's begin with what we are given. We are given log to the base a of b. We can apply the change of base formula, which we just derived. And let us change the base to b. So we'll apply the change of base formula and change base to b. In that case, what happens? Log to the base a of b can be written as log to the base b of b divided by log to the base b of a. That is the formula, correct? Now, what is log to the base b of b? It is 1. So we get log to the base b of b as 1 over log to the base b of a. And that is what we wanted to prove. So log to the base a of b is as shown. Do you see how they interchange? It's kind of important to understand these steps since it really helps in many multiple choice questions. Sometimes the choices are such that it's very difficult to decide what is the right answer. If you know these tricks or the formulas, in that case it becomes simpler. So when the base is a and the argument is b, we could always write in the reverse order, but it would be 1 over that. Perfect. Now let's take the next example. The example is to write log, so if nothing is there, the base is 10, log of 10 divided by log of 7 in a single logarithm. In a single logarithm. So how can you do this? Well, here's a clue. Let's again look at change of base formula, which is log to the base a of x. We wrote this as base change to b of x or base change to b of a. So that is the ratio. Now the idea, and in the previous case, you also understood that log to the base b of b is actually 1. Using these two identities, we could actually solve this question. So I think you got the clue. I'd like you to pause the video and now write down the answer. So we'll change the base in this case to, let us say 7. Let's change base to 7. In that case, what do you get? Well, as far as the numerator is concerned, we get log to the base 7 of 6 divided by log to the base 7 of 10, since that is base 10, right? And in the denominator, we get log to the base 7 of 7 divided by log to the base 7 of 10. Now clearly this cancels, and we know that log to the base 7 of 7 is 1. So what do we get? We get a single logarithm, which is log to the base 7 of 6. So that becomes the answer. Perfect. Now from change of base formula, this was very simple. That ratio, do you see 6 and 7? And see how it can be related. So in multiple choice questions, it is a key to understand. You can see the change of base formula. a and x, correct? That is how they are related. In that case, if you look at it very carefully, in that case, you can actually form a strategy to get the answer within no time. So these strategies are going to help you in multiple choice questions also. Okay, now let's move on and take up the next question. Now here is the next example. You need to prove 1 over log to the base 3 of x plus 1 over log base 5 of x is equal to 1 over log 15x. You can always pause the video, answer the question, and then look into my suggestions. So let's look into our special case, and we're going to use this particular formula to solve the question given to us. So remember that log to the base a of x can actually be written as 1 over log to the base x of a, right? So we're going to use this particular formula to prove the identity, correct? Let's begin with the left-hand side, which is 1 over log to the base 3 of x plus 1 over log to the base 5 of x. So we could write this as equal to log to the base x of 3 plus log to the base x of 5. And now we can use the property of product, right? So we could write this as log to the base x of 3 times 5, which is 15, correct? So which is log to the base x of 15. And again, applying the same property which we started with, we could write this as 1 over log to the base 15 of x, which is the right hand side. Is that clear to you? So that is how we are going to solve it. Perfect. Two more questions to go. Here is the second last question, which is solve for x. Log to the base 2 of x plus log to the base 4 of x plus log to the base 16 of x is equal to 35 over 4. So we need to find the value of x. Okay, so we'll change the base to 2 this time. So here we are going to change base to 2. So we get as log to the base 2 of x plus 4 could be written as log to the base 2 of x divided by log to the base 2 of 4 plus 16 can be written as log to the base 2 of x over log to the base 2 of 16. And we are given this as 35 over 4. So this could be written as log to the base 2 of x plus log to the base 2 of x, and denominator is what? Log to the base 2 of 4. 4 is 2 squared, so it is 2. And here we get log to the base 2 of x divided by log to the base 2 of 16, which is 2 to the power of 4. So I could write this as 4, right? So this becomes 4, and that is equal to 35 over 4. So let me rewrite what substitutions we have done here, right? So we evaluated log to the base 2 of 4 as log to the base 2 of 2 square, which is 2, and then log to the base 2 of 16 as log to the base 2 of 2 to the power of 4, which is 4, right? So that is how we got these two values. Now we could times by 4, right? Both sides. So we'll get rid of fractions by doing so. So we get 4 times log to the base 2 of x plus here we get 2 times log to the base 2 of x, and this is log to the base 2 of x equals to 35. Now we can combine these terms. 4 plus 2 is 6, 6 plus 1 is 7. So we get 7 log to the base 2 of x equals to 35, and that gives you log to the base 2 of x is equals to 35 divided by 7, which is 5. And now we can find what x is. So that gives you x as equals to 2 to the power of 5, right? So we get our answer, which is x equals to 2 to the power of 5, which is 32, right? So we can write here 32. So that becomes the solution for the given case. So I hope the steps are absolutely clear. So we once again applied the change of base formula and effectively solved the question. Now here is the last question for you, which is solve for x, log to the base x. Now here base is 10 of x plus ln x equals to 1. Very interesting question. So we are going to combine log to the base 10 with log to the base e, which is ln x equals to 1. Now it's better to convert this to ln, right? So we can write log to the base x as ln x. ln x is basically log to the base e of x, correct? So that is being written as ln x, natural log, over ln. So we change the base to e of 10. And this is ln x equals to 1. So we can cross multiply everything by ln 10. So we can write this as ln x plus ln 10 times ln x equals to ln 10. We can take ln x common, so we get 1 plus ln 10. ln 10 is a constant, right? ln 10. And so we get ln x equals to ln 10 divided by 1 plus ln 10. Correct? So that should give us the answer. Can you write down the exact value of the answer now? Well, we can take to the power of e, that is the inverse of ln x, right? So we could now write down this as x is equal to e to the power of ln 10 over 1 plus ln 10. Correct? So that is how we get the value. Now, if you want to get the decimal value, we can always use the calculator to evaluate. So I'm using a calculator to find the value of e to the power of, so I'll put in brackets ln 10, and the answer here is 2.0081, which we could write as 2, but sometimes we are given to write in 3 significant places. In that case, it will be 2.01. So that is to 3 significant figures. So that is how we could actually evaluate the answer to 3 significant figures for the given question. So I hope the steps are absolutely clear. Feel free to write your comments and share your views. Let's look into the questions which we have just done. So we began with the proof for the change of base formula, which is extremely important to remember. Log to the base a of x could be written as log to the base b of x divided by log to the base b of a. Now in this particular formula, if you make a small variation, and that is if you change the base to x itself, so if you change the base to x, in that case, what happens, right? So that means in this case, for example, 8b, we are changing the base to b. So in that case, the numerator becomes 1, since log to the base b of b is 1. And that is how you get this part as 1. And you kind of get interchange of the base and the function argument, right? And that really helps in answering questions like this, or even writing in a single logarithmic form. So this is a key to answer such questions. Also, we noticed that when we have a question where the bases are related, it is good to always convert the base to the lowest term and then get your solution. Sometimes you may have to evaluate your answer, as in the last case. In that case, we might have to write down the answer to three significant figures. So round it properly to get the correct answer. With that, we conclude, and I hope that helps. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.